Hello, and welcome to Chapter 9, Basics of Hypothesis Testing. So in this chapter, we're going to be going over the null and alternative hypothesis, then going over the test statistic, followed by calculating the p-value and the significance level at that p-value. Then we'll be going over one sample z-test, and then the power and sample size that are needed to calculate these tests. So here we go, here's a review of the basics of inference. So Chapter 8 we don't go over because some of it is kind of covered in Chapter 7 and the other part is definitely covered in Chapter 9. So we don't go over it, but it is a good review if you choose to look into it more. So the basics of inference is population is all possible values. The sample is a proportion of the population, right? A small sample size of the population is a proportion of it. Statistical inference is the generalizing from a sample to a population, which is calculated, which is with calculated degree of certainty. So remember, anytime you take a sample from the population, you can run data or collect data, and then you run statistics on it, and then infer back to the population. We'll see this as an illustrated example in the next slide, I believe. And there are two forms of statistical testing. There's hypothesis testing and estimation. So the basics of inference, you have parameters, which is a numerical characteristic of a population, population mean, shown as mu here, and the population proportion as p. And then a statistic is calculated value of the data set as a sample mean x bar, and a sample proportion as p hat, a little doodad up top called a hat. And so notice the difference in the symbols. One is for the parameters of population, the other one is from the data in the sample set itself. So the distinction between parameters and statistics, the parameters, once again, is a population, which uses Greek notation, and then you have statistics, which draws its information from a sample and uses Roman characteristics, i.e. x bar. You can, from statistics, the statistics can vary and it's calculated, yes, but from the parameters, you cannot. So here's the picture I was just mentioning about. So here you have your population. Well, actually here you have your population. And from the population you draw a small little subset of it, and that's going to be your sample. And then from your sample you collect your data. Once you collect your data, you can run statistics on it, right? We can figure out the average, figure out the standard deviation and whatnot from it. And then from the statistics we can actually infer back to the population and draw inferences about it. You can infer back your inference about it, and this is kind of like the diagram in place for that. So in Chapter 8, how a sample mean varies. So sampling distribution of a mean tends to be normal, with the expected value equal to the population mean as mu and standard deviation, and we get this formula called the standard error of the mean right here. Standard error of the mean, which is equal to the standard deviation over the square root of n. Standard deviation of mean and standard error of mean are synonymous, meaning the same thing. Remember, anytime you see expected value, it's going to be the mean of some kind. So standard error of the mean, standard deviation of the mean. So now we're going to get into the introduction to hypothesis testing. Hypothesis testing is also called significance testing. The objective of hypothesis testing is to test claims about parameters. The first step is to state the problem, then follow these 4 steps. So these are the steps in which you will use. First step is to state the null and alternative hypothesis. We'll go into more detail about them, but you're going to state the null and alternative hypothesis to what you're testing. Remember, a hypothesis is an educated guess to what you believe is going to happen. That is your, what we call, alternative hypothesis. Next, you're going to run your test statistic, followed up by calculating your p-value and an interpretation of it, and then you're going to provide the significance level of it, of the p-value. Understanding all 4 steps of testing, not just calculations. Remember, you want to make sure you understand what we're doing in each one of these levels and why we're doing it, right? We want to state the null and alternative hypothesis first, then do your test statistic, then get your p-value, interpretation, and your significance level. If you do this right and in order and correctly, things will flow much easier for you when you go out and do research. So in section 9.1, the null and alternative hypothesis. So to convert the research question to a null and alternative hypothesis. Remember, when we have a question, we're going to have, that's going to be your alternative hypothesis, something you're disproving to the null hypothesis. The null hypothesis, you'll see it as H subscript 0 or H naught, or the just stated null hypothesis is a claim of no difference in the population, right? This is stating that this is the standard quo, this is what is commonly accepted as fact, this is what we go off of, and this is what we try to disprove. The null hypothesis is commonly accepted fact, like I just said. This is what researchers are trying to disprove. The alternative hypothesis, the HA, is the claim of difference. It's the opposite of the null hypothesis. It seeks evidence against the null as a way of bolstering the alternative hypothesis. So here's an illustrated example of body weight. So the statement is, in the 1970s, we have 20 to 29-year-old men in the United States had a mean body weight of 170 pounds with a standard deviation of 40 pounds. We want to test whether the mean body weight in the population now differs. So the way we set this up, we set up our null hypothesis states that mu is equal to 170. That's what the average weight was, and we say mu is equal to 170. And the alternative hypothesis can be stated one in three ways. For now, we're just going to go over two. And it can be stated that the mu is either going to be greater than 170 for a one-sided alternative, or the mu does not equal 170, a two-sided alternative. So here's our test statistic, and I'm going to stop the video here and pick it back up in part 2. Remember, we're just setting up our null and alternative hypothesis. Remember, our null hypothesis is mu is going to equal a certain amount, and then our alternative hypothesis is going to say that it is different in some way, whether greater than, less than, or not equal to. For this example, we just went over it's either going to be greater than or not equal to. All right, I will see you all in part 2.